problems based on cylinder. First one, 2.2 cubic decimeters of brass is to be drawn into a cylindrical wire 0.25 centimeters in diameter. Find the length of the wire. Solution: here some volume of brass with 2.2 decimeter cube is used to make cylindrical wire with diameter 0.25 centimeters. Now we need to find the length of the wire. So let given volume of a brass, volume of the brass equals to 2.2 decimeter cube. Now diameter of the wire equals to 0.25 centimeters. Then radius of the wire that equals to R equals to half of that, 0.25 by 2 centimeters. But volume is given in decimeters. Convert this into decimeters, then you'll get 0.25 by 2 into 10. On dividing with 10, centimeters is converted into decimeters. Now volume of cylindrical wire is nothing but the volume of brass, because there is no change in volume, same brass is used to make the cylindrical wire. So pi r square h equals to 2.2 22 by 7 into 0.25 by 2 into 10 into 0.25 by 2 into 10 into height h is equals to 2.2 2.2 ones, 2.2 tens, 10 cancel, then h equals to 7 2 10 are in the denominator, send them into numerator of right side, 2 into 10 divided by 0.25 into 0.25. Now h equals to 7 into 4 into 10 into 100 into 100 by 25 into 25. I'm converting 0.25 into fractions, that means 25 by 100. So 100 will come in the numerator here. 25 ones, 25 fours, 25 ones, 25 fours. If you observe, 7 10s is 70. So 4 into 4 into 4 keeps 64. That equals to 0 28 4480 decimeters. If you divide with 10, you will convert them into meters, that is 448 meters. That is the length of the wire. I'm going for the second question. 50 circular plates, each of diameter 1.4 centimeter, 14 centimeter, and thickness 0.5 centimeters are placed one above the other, one above the other to form a right circular cylinder, find its total surface area. Solution. So here we have 50 circular plates. That means circular plates with thickness means each plate is in the shape of cylinder, and when 50 plates are piled up, it forms other cylinder with the height 50 into thickness of the each plate, and diameter will not change. So diameter of the plate D equals to 14 centimeters. Then radius of the plate, R equals to 14 by 2, half of the diameter, 7 centimeters. Now height of the cylinder form equals to 50 into thickness of each plate, that equals to 50 into thickness of each plate is 0.25 centimeters, 0.5 centimeters, 0.5 centimeters. That means 0.5 can be written as half, 50 into half centimeter, then you will get 25 centimeters. Now we have the cylinder with height h equals 25 centimeters, radius 7 centimeters. Now you can find the total surface area of that. Total surface area of form cylinder equals to formula 2 pi r into r plus h or h plus r. That means 2 into 22 by 7 into 7 into 7 plus 25. 7 cancel. 44 into 32. 7 plus 25, 32. 44 into 32. Then you will get 1408 centimeters square. So this is the total surface area of the cylinder. Problem based on cylinder. First one, a cylindrical jar of radius 6 centimeters contains oil, iron spheres, each of radius 1.5 centimeters are immersed in the oil. How many spheres are necessary to rise the level of oil by 2 centimeters. So now we have the cylindrical jar with radius 6 centimeters, contains some oil up to some extent, some height. Now some iron spheres of radius 1.0 centimeters are immersed in the oil. Now
the oil height of the oil rises to 2 centimeters. Now we have to find the how many spheres are there. Let me get the figure first. So this is the cylinder with radius r1 equals to 6 centimeters. Now we have oil up to certain height, up to certain height up to certain height, this height. Okay, now of a cylindrical jar equals to r1, that equals to 6 centimeters. A radius of each iron sphere, radius of each iron sphere, that equals to r2 equals to 1.5 centimeters. Now height of the oil level raised equals to h, that equals to 2 centimeters. No, so whenever the spheres drop with radius r2 equals to 1.5 centimeters drop, the oil was raised to certain extent, which is 2 centimeters. Therefore, number of spheres into volume of each iron sphere equals to volume of oil level raised, means n into volume of each sphere further pi into r2 cube, because r2 is the radius of iron sphere, pi r1 square into h, pi get cancelled, n into 4 by 3 into, so you can write 1.5 as 3 by 2, so 3 by 2 centimeter, 3 by 2 whole cube, that equals to r1 square 6 square into h 2 centimeters, then n equals to 6 into 6 into 2, 3 will come here, 3 and 2 cube, so 2 into 2 into 2 whole divided by 4 into 3 cube, 3 into 3 into 3, because 3 by 2 whole cube, 3 by 2 3 by 2 3 by 2 reciprocals, 3 ones 3, 3 ones 3 twos, 3 ones 3 twos, 2 twos are 4, 4, we'll get 2 into 2 into 2, 2 power 4, that is 16. For number of balls, iron spheres immersed in the oil is 16. Going for the second problem. A cylindrical tub of radius 12 centimeters contains water to a depth of 20 centimeters. A spherical ball of radius 12 centimeters, sorry 9 centimeters is dropped into the tub, and thus the level of water is raised by h centimeters. Find h. So we have the cylindrical tub with radius r1 equals to 12 centimeters, and the depth of the water in the tub is up to 20 centimeters to 20 centimeters. Now when spherical ball is dropped with radius r2 equal to 9 centimeters, then the water level rises up to h centimeters. Now we have to find this h. Now let a radius of a cylindrical tub equals to r1, that equals to 12 centimeters. A radius of a spherical ball, that equals to r2, that equals to 9 centimeters. Height of water raised, that equals to h. Therefore volume of water level raised, the volume of water level raised is nothing but the volume of the sphere, equals to volume of spherical ball. So volume of pi r1 square h equals to 4/3 pi r2 cube. Pi get cancelled. r1 12 square into h equals to 4/3 into 9 cube. Then h equals to 4 into 9 into 9 into 9 by 3 into 12 square, 12 into 12. 3 ones, 3 threes, 3 ones, 3 fours, 4 ones, 4 ones, 3 threes are, 3 fours are. Then h, water level raised, equals to 9 threes are 27 by 4, that equals to 6.75 centimeters. Going for the next problem. Prove that the surface area of a sphere is equal to the curved surface area of circumscribed cylinder. Means the total surface area of the sphere must be equal to the cylinder which circumscribes the sphere itself. Solution. That means if you observe that diameter is nothing but the height of the cylinder, and radius of the cylinder must be equal to the radius of the sphere. Diameter of a sphere is nothing but diameter of cylinder, that equals to height of the cylinder also. That means, so both diameters equal d, that is equals to h. D means 2r, then h equals to 2r, let it be 1. Now total surface area of a sphere equals to 4 pi r square. Curved surface, let it be 2. Curved surface area of a cylinder equals to pi r square h, from 1 pi into r curved surface area 2 pi r h, 2 pi r h, 2 pi into r into h equals to r from equation 1. From equation 1, 2 2s are 4, r into r square, equation 3. Observe that equation 2 equals to equation 3. That means total surface area of the sphere is nothing but curved surface area of the cylinder circumscribing the sphere. Problems based on cylinders. First one. What length of a solid cylinder of 2 centimeters in diameter must be taken to recast into a hollow cylinder of length 16 centimeter, external diameter 20 centimeters in thickness, 2.5 mm. See the question once. We have the cylinder. With diameter 2 centimeters. That means radius r1 equals to 1 centimeter. Now we have to find the length. That means height of this one, h1 of this height of the cylinder. Let r1 be the radius of the given cylinder, h1 will be the height. Now this cylinder is recast into hollow cylinder with external diameter, that means external diameter 20 centimeters, d2 equal to 20 centimeters. That means you can get that r2 equals to 10 centimeters because radius is half of the diameter. Now then this will be the r3 internal radius. So now we have to get let radius of first cylinder or solid cylinder is equals to r1, that equals to 1 centimeters, height of solid cylinder, that equals to h1. Now this height is given 16 centimeters, this length is given 16 centimeters. Now outer radius of hollow cylinder equals to 10 centimeters, which is r2. Inner radius of hollow cylinder, that equals to r3 equals to outer radius minus thickness. So he given 2.5 mm is 0.525 centimeters. That means 10 minus 0.25, you will get 9.75 centimeters inner radius. Now there is no change in the volume, so simply solid cylinder is recast into the hollow cylinder. Now volume of a solid cylinder, solid cylinder is equals to
volume of a hollow cylinder. Volume of a hollow cylinder. So volume of a solid cylinder with R1 H1, that means pi R1 square H1, that equals to hollow cylinder volume means volume of the external cylinder minus internal cylinder. That means you have to get external volume minus internal volume. So pi R2 square H2, because this is H2, height of the second cylinder, minus pi R1 square H2. That means pi R1 square H1 is nothing but pi into H2 into R2 square minus R1 square. Sorry, this is R2, this is R3. Okay, because R2 is the outer radius, R3 is the inner radius. R2 square minus R3 square. Pi get cancelled. R1 1 square into H1 equals to H2 16 into R2 10 square minus 9.75 whole square. Then H1 equals to 16 into 10 square, you will get 100, and 9.75 whole square, you will get 95.0625. Then H1 equals to 16 into 100 minus 95.0625, it will give 4.9375. Then H1 equals to 16 into 4.9375 will give 79 centimeters. So this is the H1. So we can go further problem. Next problem. Second one. A cylindrical vessel having diameter equal to the height equal to height is full of water which is poured into two identical vessels with diameter 42 centimeters in height 21 centimeter, which are filled completely, find the diameter of the cylindrical vessel solution. Now we have the cylindrical vessel in which diameter of the vessel is equals to the height of the vessel, and there is full of water in the vessel. Now we have two more identical vessels with diameter 40 centimeters and height 21 centimeters, which are filled completely. So that means the water in the first cylinder were poured into two other identical vessels with diameter 42 centimeters and height 21 centimeters. Now we need to find the diameter of the cylindrical vessel. Solution. Let height of the cylindrical vessel, that is equals to diameter of a cylindrical vessel. It will be h, height will be h, and diameter is d. But diameter can be written as 2 into radius. 2 into, so h equals to 2 radius. Now height of two identical vessels equals to h1, that equals to 21 centimeters. Diameter of two identical vessels, that equals to d1 equals to 42 centimeters. That means radius r1 equals to 21, half of the diameter. Now see, the volume of the big vessel must be equal to the sum of these two identical vessels. So volume, because the total water in the cylindrical vessel is used to fill these two vessels completely, so there is no change in the volume. Volume of a cylindrical vessel equals to sum of volume of two identical vessels. Therefore cylindrical vessel pi r square h equals to pi 2 into pi, because two vessels are the 2 into pi r1 square into h1. So pi get cancelled. R square into 2h into 2 into r1, 21 square into 21. So 2 get cancelled. R square, sorry, 2, this is 2r, h equals 2r from this. So r square into r, that is r cube, because we have to replace h equals 2r here. 2 get cancelled. R square into r cube equals to 21 square, means 21 into 21 into 21. Therefore r equals to 21 centimeters. R equals to 21 centimeters.